Okay.
clear light off
sir. Okay, go on. Start. Yeah, do it.
Okay, next we move on to bearing. Bearing assembly is used to drive the bearing. Conformity test method is designed to verify the bearing assembly factor is critical in non-coating issue. The bearing assembly was replaced with a known defective bearing to understand and study the impact. The defective bearing assembly obtained from previous maintenance work that was carried out. So what basically we did here was to change the inner bearing. The whole thing is actually an assembly. We replace it with previously known defective bearing assembly that we obtained from the maintenance team. We changed with the defective bearing to understand its impact to this study. From that experiment that we did, we found out few points. First of all, we used 10 product samples. The experiment executed using both defective and good bearing. The reason for using 10 samples is to have a better data set point. Based on the study, the following was observed. So for 10 product, for the defective bearing, all 10 panels came out without coating. And the good bearing, which is the normal standard condition, all the panel has been fully coated. So from there, we learned that the defective bearing plays a role in the non-coating condition. As I mentioned earlier, from the conclusion, from the experiment done, it was found that the defective bearing caused the products to move to the next station without any stoppages. And this in return causes the panels moving to the next station without any coatings. The defective bearing could cause significant impact in the proper coating process. Next, we move on to metering valve. For our next experiment, which is conceptualized to test metering valve, the conformity test method that is designed to simulate a defective valve, and that is done by setting the metering valve similarly like the supply valve. The experiment that we do for the metering valve is almost similar as what we did for the supply valve, which was our experiment number 1 in 4 different conditions. The function of metering valve is to lower down or raise the applicator roller. This hypothesis is conceived to study the impact of metering valve not functioning fully, which means it's open quarter, half, and fully closed. The scenario of it being open fully is also added to the experiment as a control factor. The degree to which the valve is being opened is controlled by varying the pneumatic supply to the valve. As mentioned, there are 4 possibilities to set up the metering valve. At the same time, in the event of the metering valve movement is interrupted, the preceding events will be studied. The conformity test method is done by setting up the metering valve in 4 different conditions. So the 4 different conditions are metering valve quarter open, half, fully closed, and fully open. The condition 4 is as our experimental control. Right? That is the intended setup. Right? These 4 different conditions actually replicates the all possibility that would happen to the metering valve and the corresponding effect to the machine was studied. 3 tests are conducted for each condition, and each test is done using 10 products. This is done to have a better reliability and more assertive data. The opening of metering valve will determine the height the roller will travel. In normal circumstances, the valve will be fully open. So these are the results from the metering valve experiment. So based on the 10 product, when we quarter open, the triggering point is whether the machine stops. The answer is no. When it's half open, no. Fully closed, no, it didn't open. But when it's fully open, it also didn't machine alarm, it didn't alarm. So this is how we do the test. So how does we conclude this experiment? This experiment shows that irrespective whether the metering was closed or open, there will be no stoppages to the tool. The simulated defective valve did not stop the machine. The panel move on to the next station. In the event there is any interruption to the pneumatic supply or issues with the metering valve, the products will still pass without applicator rollers being lowered down to apply solution on panels. So with that, we conclude metering valve can be a culprit as well for this issue. So overall experiment summary. The following table summarizes the parameter that was experimented and tested in order to realize the nature of failure. The hypothesis selected is based on the most probable occurrence. So in the next slide, I'll show the table that summarized all the parameters that was experimented, and it actually basically summarized whatever we have gone through in the last few slides. So finding from the experiment, based on the study done, it's confirmed that the mechanical failures are the reason for the non-coating panels. So the box that's highlighted in red, these are the possible mechanical failures that can happen, right? So and these are the mechanical failures. So from the overall test that we done, we have come to a conclusion that any failures on the mechanical assembly parts will cause non-coating panels, right? So next, I'll introduce to the solution that come out for this problem.
Yes.
How to detect the non-coating panels.
That is what I'm really interested on.
Happy to hear that.
Yeah.
Based on the outcome of the experiments conducted, it could be safely concluded that NPR system does not have any capability to provide inline reaction in the event of mechanical failures. If there is any mechanical failures, there will be no alarm and the machine will continue processing and it will produce panels that are not coated. And it's very hard to determine this kind of panels with naked eye. As I mentioned, the reason for this is on the light setup. To mitigate this and further enhance the tool capability, Kaizen option was explored and the non-coating detection system was established. An NPR non-coating detection system is totally independent from current NPR system, and no coating triggering is by a revolving lamp and a buzzer system. The system will ensure that there is a detection to catch any panels that are sent to without coating. The main component of this system are photo sensors, fiber optic sensor, triggering systems, and this system will detect the panels that are not coated and prevent panel scrap. Okay, this is the overview of the system. Alright. So generally, this is the product, before coating product. This is the machine. And we have a sensor here, the photoelectric sensor and the fiber sensor head. One will detect the arrival of the panel and the other will detect whether the panel is being coated or not. Right? So this is the actual setup from the machine. And then we also put in a revolving light.
Okay.
So in the event there is a known coating, the alarm will trigger out and then the operators could react accordingly. Right? This is the control box for the machine. Right? This is the control box for this design. This here. Okay. So what does each of these does? Right. So working principle of the non-coating detection system. The system uses both fiber optic, red light source, and photoelectric sensor. Photoelectric sensor is used to detect the panel arrival, while the fiber optic sensor is used to trace coating reflection. This is ideal for sensing environments with light restrictions, such as our place where the light sensitive film is being handled. We have a yellow light, and this is the best solution for it. The system includes full auto teaching function, which allows sensitivity to be set without stopping to work this time. Once a panel without coating is detected, the system will trigger a buzzer and a revolving beacon lamp. This triggering will create an awareness to the operator, and they in turn could react to the situation accordingly. This is what we want. We don't want any panel to reach the final processing area or even reach to the customer for this case. So, introduction to some of the items that have been used in this project. What is fiber optic? The system uses both fiber optic, red light source, and photoelectric sensor. An optical fiber is a flexible, transparent fiber made by drawing glass or plastic to a diameter slightly thicker than of human hair. Optical fibers are used most often as means to transmit light between the two ends of a fiber and has a wide usage in fiber optic communication where they permit transmission over long distance, and it also has a higher bandwidth. Fiber optics is not a scan technique, but it's another method for transmitting light. So fiber optics sensors use an emitter, receiver, and a flexible cable packed with tiny fibers that transmit light. Next, we go to another sensor that we use for this project, photoelectric sensor. Photoelectric sensor is another type of positioning sensing device. Utilizing a modulated light beam that is either broken or reflected from the target, the control consists of an emitter and a receiver to detect the emitted light, and associated electronics that are evaluate and amplify the detected signal, causing the photoelectric output switch to change state. A self-contained photoelectric sensor contains the optics along with the electronics. It requires only a power source. So the sensor actually can perform its own modulation or demodulation, amplification or output switching. So this is the benefit of the photoelectric sensor. So this is how we set up the sensor. We have the photoelectric sensor here. This is the picture from the actual implemented area. And we also have the controller. Controller for this project is stored in a special control box by the tool. It has a reset button so that the system can be reset once the non-coating detected. So once we recover the situation, we can actually reset the condition. At the same time, the controller also has the option to turn off the breaker, and this option could be utilized in the event of any emergency. The controller box provides adequate support for all ports and connections. This is very important as to prevent any moisture from entering critical parts. So bearing in mind the condition of the place that we are working on, there is always a possibility of moisture to seep through the ports. So in order to prevent the damages, we have the control box. Next, we have the beacon or revolving lamp. So once the panel without coating is detected, the system will trigger buzzer and a revolving beacon lamp. So we selected this one specifically because we can see this lamp even from the manufacturing office. You can actually see it from manufacturing office, and there will also be an alarm. So result and discussion. The incorporation of the new detection system as a part of the case approach does not have any impact on the existing line. The following parameters was observed to ensure that there was no shift in the process with the incorporation of the new detection system. The following will show some of the data from the pilot run. Okay. Line parameter evaluation. So what are the parameters that we will be looking at to evaluate whether this system, the newly introduced system, is creating a different problem, right? Or how do we ensure that it's running in a intended condition? So the first parameter that is compared is efficiency, right? Efficiency actually is related to solar cell, which is related to the company that I'm working in now, right? So solar cell efficiency refers to the portion of the energy in the form of sunlight that can be converted via photovoltaics into electricity. For all data analysis, JMP software is used. JMP software is very useful as statistical software, as I mentioned earlier. The efficiency of the solar cells used in the photovoltaic system in combination with latitude and climate determines the annual energy output of the system. For example, a solar panel with 20% efficiency and the area of 1 meter square will produce 200 watt at a standard test condition or STC. This is how we test our solar panels. And the most important takeaway point from here is that the word efficiency. So whoever in this industry, right, they will emphasize on efficiency because efficiency is the ability of the product to absorb sunlight. So since company has used two identical lines to run this product, the data from both lines is mined for verification. Both lines should be running efficiency at the same level with minor differences. So actually, day in, day out, we have process engineers who monitor the efficiency level of both lines. So if let's say one is at high and one is at low, then it means that there's some issue. So we have to look at the machine, any of the machine, right? So our ultimate goal is that we have data that is identical to each other. Okay. And efficiency is, as I mentioned, is closely scrutinized. After the implementation of this project, the efficiency trend for both this line was monitored for a period of time. From the data above, which is extracted using JMP software, we see that the trend for both lines are almost identical and without major deviation. I'll show the graph in the next page. So this is the efficiency. Right? So this is when we implemented, and if you can see that before we implemented, both line 1 and line 2 were running almost identical. Right? So after implementation, it's also the same case. Alright? This one will give a better picture. So, right? So this is the trend. So there's no deviation was noted between the line. So this is the efficiency trend, right? So it's consistent when you compare with both lines. So this is a project basically one-way analysis to check the efficiency. So when you have this kind of turnkey, so it shows that the process is consistent. Next parameter that we see is STBI. STBI is actually indication of stability of the product. So when you go and install this product, we need it to be stable for say 25 years. We cannot have a product that when you send to the customer, after 2 or 3 years it start to exhibit deteriorating condition. So this is another parameter that we see. So we want to check whether the introduction of the non-coating detection system will bring any deviation of the STBI data, right? So we took usually STBI data is recorded for 7 days, right? Continuous 7 days to check the performance. So from here we can conclude that the process is stable and it does not have any impact on STBI. The product that's pulled from the run is sent for offline data analysis, and this could be seen that the data is consistent with the good product lifetime. This indicates that the implemented project does not have any bearing towards the performance of the product. So basically we mix the product, right, and then send to the upstream processors, and based on that we can see a consistent trend. What is abnormal will be you have some panels showing the data here. Right? So in terms of cost saving for the first project, this is the template that is used by my company. Right? So we forecast that we will get back a return of 310,000 USD within the first year. But this was the first time analysis. Later part, because this project was done in a period of 4 years time, right? So in the later period of time, we noted that these values actually more tremendous than what we anticipate in the beginning. I will show the figure later.
What was your percentage with that?
Nothing. Just get them.
Sounds good.
Yeah.
Okay, go on.
Actually, this project I presented in a company level competition and I won this project. So we got some monetary things for it. Okay, validating the effectiveness of the solution. A 3-year study was done to understand the effectiveness of the implemented project. The reason why 3 years is selected because to ensure more integral data is available. So 3 years data is collected either personally or through shift supervisor. Then the data is compared with system data. So this company is fully automated and computerized. So you can pull in the historical data even from 7 or 8 years ago. Everything is there. So we compare the system data and also from personal interview with the shift supervisors. Based on the data collection, more understanding about the problem and effectiveness of the project was studied. Right? So 2012 number of occurrence, 15 number of occurrence, 14 number of occurrence. So number of detection. So what the graph shows is that whenever there is an occurrence, it's immediately detected. I can show another. Okay. So these are the number of occurrences and the detection details. Right? So in 2012 we have in January we have one occurrence and it was detected immediately. So if you look at the figures, it jives.
Is that periodic? I mean, there is a relationship between the occurrence, is there?
There's no relationship between the occurrences. It's when it happened, we just take note of it. So this is the gauge attribute chart agreement. All this data actually shows what I had mentioned in the earlier slide. Shows that occurrence and detections are matched. Same thing. So conclusion and recommendation.
Yeah.
Right. So in summary, the non-coating detection system was found to be an effective way of controlling the unintentional movement of non-coated panels and maintaining the panel coating with specification limit. The idea which came from literature review of case and related journals and applying the concept has produced a fruition. The intentional mechanical failure induced was able to detect by detection system. With the introduction of sensor beam on the panels, no destabilization factors that are induced on the coated panels. NPL coating has been noted to apply uniformity. Although this is a remote possibility, we always had that worry when we introduced this project. When I first come out idea to use the photoelectric and the fiber optic, I was worried that it could cause some destabilization factors on the panel, and it has proven that it's not the case. Right? 3 years monitoring data shows the number of occurrences matches with the detection and indicates the system is working as what it intended to be. So in 2012 we have 6 occurrences and 6 detection. So all match accordingly. So the following slide will show analysis by event, right? 2012, 2013, 2014. So what we need to see here is that it shows that the score is equal, meaning that the detection and occurrence is the same. So this is to further validate the data that we have compiled, right? So the one-way analysis that is done shows the leverage of equal score means that indicates the occurrence matches the detection perfectly, but the analysis is done based on the event. Okay, so we have done a wonderful project. What does it actually means to the company? What we have done actually? So without the system, the losses of the company would have been great. To put the matter into perspective, potential panels that could be scrapped, right? So over the year, so how do we come out with this figure? So whenever there is a non-coating detection, when we have the alarm, right? So we will calculate, we have a system to calculate the number of product in that conveyor, alright? So based on that, we found out that in 2012, we saved about 2754 panels or products, 2013 1996 product, and 2014 2856 product. Okay. So this is the distribution events that the panels could be scrapped. The number of potential panels that could be scrapped is obtained based on the capacity planning that was in place during the time. As I mentioned, there is a system. The panel that accidentally skipped to the coating process will need to be scrapped as there is no means to service them. That is the reason it's important to have a detection system. If the panels to be scrapped, it presents a huge loss to the company. This is the point that I reiterated earlier. So the avoided losses, right? So when we take the panel, we do the calculation. This is the figure that we're getting in US dollar. So in 2012, we saved about 16,524,000. Right? So these are the values.
You should open a company for this.
Consultant.
Yeah, become a consultant then.
Hopefully with this,
Yeah.
great.
Yes, go ahead.
So recommendation, based on the study of the best improvement to ensure the early detection of non-problem panels will be the development of the implemented system, as the system is proven in detecting problem panels and case method is effective in the system development. Although the issue sounds like small, the collected data shows that the amount of money that we saved is huge. The final product that was designed as a result of this study has set up shown on the figure. Next page. So this is the system overview that I went through earlier. So my concluding points. In summary, the effective way to control the unintentional movement will be the non-coating detection system. Okay. So these are my concluding points. And some key points here is that the reverse solution using Kaizen as a platform has many potential. It could be used in many manufacturing sectors, especially those using photoresist. Since photoresist technology is widely used, the solution could be better enhanced by incorporating other features such as the ability to stop the upstream processor. This is possible to have by having a detailed PLC program. So the solution that was developed for this company, right, it can be also used for many other companies that uses photoresistors to check for the coating. And it can be customized to their needs to have to create the ability to stop the upstream processes, right? Further studies on these features discussed above could be done, and the benefit will be there for all to see. As one of the most important results of this research, a system to detect the non-coating condition has been compiled, filling a gap in this field of photoresist. So basically, there is no other study that has been done on this to detect. So I believe my research work has filled the gap of the field of photoresist. It is expected that it will contribute to raising interest in the topic and in the formulating, developing of future work in the field, both in academic sphere and among manufacturing companies. Suggestion for further work: it's necessary to have a good detection system on any potential problem that could be resultant panels move on without putting. Future studies will be on having and detection system that will be able to provide inline detection. Okay, with that I conclude my presentation, and as an acknowledgement, I like to have a special thanks to all who assisted in this project by providing inputs and encouragement. With that, I end my presentation.
Yeah, it's end. But you have published a journal paper.
Yes.
Could you please open it up? You did bring it.
Let me check.
Please. Eight. You have two slots or something.
Okay, this is the journal paper that I published.
Corporate non-cutting issue in manufacturing industry. Okay, go to the conclusion part. Yeah. Yeah, please explain me some.
Okay, what I written here is actually comes from my work on my thesis, right? So, in summary, the non-coating detection system was found to be an effective way of controlling the unintentional movement of the non-coated panels and maintaining the product's coating with specification limit. So, this is the point that I highlighted earlier in the thesis. So, as I mentioned earlier, the idea came from literature review and applying the concept. Okay. So, another point that I mentioned here is that the intentional mechanical failure induced was able to be detected by the detection system. So this is how we know that our detection system working fine, by creating an intentional mechanical failures. So another key point is that with introduction of the sensor beam on the product, no destabilization factors are induced on the coated products. Right? So the NPR coating has been noted to be applied uniformly. So based on the study, to the best improvement ensure the early detection of the non-coated products will be the development of the implemented system, as the system is proven in detecting problems and Kaizen methods effective in system development. So these are my concluding points for my.
Yeah, because you told me just now that some data are confidential information. So will this create any problem to IIC UT?
No, actually the data that I share here, right, is the general data.
Oh.
I only didn't share the proprietary on the type of process that we are running, you know, the recipes, all that I'm not sharing. And I don't even share the list of the equipments that we have in the machine in our company. So this data are common data.
Yeah, we don't want any IP issues. So I have to make sure that you don't exceed the limits of
Yes.
data. Okay, then fine. And you can leave the room now for 5 minutes. Then we will call you back in short while.